Hello, welcome to Enots Engineering. I'm Alan. Today we use our tramming gauge, which was made in previous videos, to set the mill spindle true to the table. Now this has not been changed since I had the machine, and I've decided that it was a good opportunity to check how accurate the machine was when it was supplied. This mill tramming gauge consists of a steel bar, a centre spindle that's pressed in, dial indicator, a bronze or brass bush that holds the indicator, which is split, and on the end cap head that clamps the indicator. Now by inserting a bronze bush or brass bush into the bar, when you clamp the indicator, the bush will close onto the dial indicator and hopefully prevent damage to the indicator. So let's go into the workshop and see how we do it. Tramming the mill is setting the spindle square to the table, and we do that by using this gauge. And all it is a spindle, and the distance between the dial indicator and the centre is enough cover from the centre of your table to the edge of the table, so that you can get a full sweep of this on the table. So if you've got a wider table, this distance needs to be wider. A narrower table, you can bring the dial indicator in. I fitted the test bar into an ER20 collet, held in the collet holder in the spindle. I've put two parallel strips across the table, one on each side, and I've made sure there are no bumps or lumps on the parallel strips or the table. So what I'm doing now is I'm lowering the spindle. If you look at the clock on the right, I'll just lower it till that clock goes to 0. This is in tenths of a thou. So that's 0 there. Using a spanner on the drawbar at the top, I'll rotate the spindle round. Rotate the spindle round till it's parallel again with the table. So if you look at that dial indicator, it's not touching the parallel strip. So what I'll do is lower the spindle. I'll set the spindle to 0, and I'll lower the spindle until the clock goes back to 0. Just about there, and that's telling me that that is 0.35 of a millimetre out. So that means that this side is 14 thou higher than this side. So I'll have to move the spindle about 7 thou to get them equal. And that's over a distance of 8 inches. Now we need to adjust that to see if we can get it a lot better than 14 thou. On this side of the head you can see there's a nut there which you slacken off so you can tilt the head. There's another nut just inside the casting up under here to slacken off. On the other side it's just here. So that looks just over the thickness of the line, just over 0. So I've undone the bolts and just tap the head. When you tighten the bolts up, the dial indicator moves. So now I'll come down onto the parallel strip get the clock to 0. Set my spindle to 0. Now, using a spanner on the top of the drawbar, I'll rotate the clock round till it's parallel. You can see that the finger has passed, and that is now, it's about 2.5 thou past the point, over 8 inches. So before it was 14 and now it's 2.5 thou. So when adjusting the mill, the way I did it is this is the thickest part, the casting here. This is hollow, so I didn't do it on this part. I just put a block of wood on there with a rubber mallet, just tap the wood with the nuts slackened, and it just, looking at the dial indicator that's already on the machine bed, you can tell when it moves. I just tapped it there to move the dial indicator until I could get the reading down to an acceptable level. And once you've adjusted it with the spanner, just put the spanner in, make sure it's tight on the 3 nuts that hold the head. Turn the dial indicator around until it touches the other side. And that size, the head is 1 thou over 8 inches out of square. So for 1 thou it's not worth messing about with it. So I'll go back around again and just check that the other side is still 0. I've tightened the 3 nuts, but the scale doesn't look as if it's moved. Well, I've got the dial indicator in the machine. I thought I'd just check the clock jaw run out. So I've lowered the clock down onto the top of the back jaw. I've just found out if I remove the guard, it still thinks the guard's there, so it then lets the power on. So now I can now that's showing a run out of 7/10 of a thou over the top of the rear jaw. And when you're finished, just undo the nut. Remove the bar from the collet. Well, that's it for today. I hope that was interesting and hope to see you next time on Enots Engineering.